Okay guys, so question 3a, the decomposition of H2O2 into water and oxygen gas follow the first order reaction. In 50 minutes, the concentration of the H2O2 decreased from 0.5 molar to 0.125 molar. Indicate the rate of oxygen formation when the concentration of H2O2 reaches 0.05 molar. Okay, so this type of question, the first thing that you need to do is you need to know that you need to write the rate expression in order to get the final answer. So in prior using the rate expression, you actually need to use the first order reaction first. So you need to use the rate law and then combine with rate expression. Okay, referring to the question, the decomposition of H2O2 will produce water and oxygen. So you need to write this equation first. So decomposition of H2O2 will produce water and oxygen gas. So can you balance this out? So we only have 2 oxygen and 2 hydrogen. So we already have 2 hydrogen here. So this one, 2 plus 1 equivalent to 3. So how are you going to make it into 2? How? So we need to times 1 over 2. This one, right? So 1 plus 1 equivalent to 2. So this is your balanced equation. So in the question also states here that this reaction follows the first order reaction. So the first order reaction, you need to remember the formula for the first order reaction is ln AT equivalent to negative KT plus ln A naught. So in the question, what else? See, in 50 minutes, the concentration of H2O2 decreased from this molarity to this molarity. So from 2. So 2 is AT. So ln 0.125 equivalent to negative KT plus ln, what is your A naught? So your A naught is 0.5. So 0.5. What are the other things that you have in the question here? In 50 minutes, right? In 50 minutes. So means your T is 50. So ln 0.125 equivalent to negative K T. 50 minutes plus ln 0.5. So from here you should get the value of K, right? The value of K should be equivalent to 1.3864 divided by 50. Okay, so you should get your Ka equivalent to 0.0277. This is the value of K. Okay, the next thing that you need to do is you look back at this equation. Don't worry, we'll not do things that we are not going to use anyway. So now from this equation, you need to be able to write the rate expression. This is your rate law. Now you need to write the rate expression. Okay, so moving on to the rate of expression. So rate expression for this reaction is whatever in the reactant must be negative, right? So here negative delta concentration of H2O2 delta T equivalent. Make sure that you write equivalent here. Equivalent to delta concentration of water delta T and delta concentration of oxygen delta T. So if you can see here, it's 1 over 2, right? So if for rate expression, it should be 1 over whatever value that you have here. So 1 over 1 over 2, right? So in the question, you were asked to calculate, indicate the rate of oxygen formation when the concentration of H2O2 reaches 0.05. Okay, so now the K. So how can you use the K? But you need to use to find the concentration of oxygen first. So it means that red, the thing that you know is only H2O2, right? So negative concentration of H2O2 delta T is equivalent to 1/1/2 delta oxygen delta T. So I've already copied the rate of expression that we have calculated just now. So it's the same thing here. So from there, you need to move on because it asks you to indicate the rate of oxygen. So we are going back. So rate. So because this is a first order reaction, right? Rate is equivalent to K concentration of O2. Right, because you want to find the concentration of O2. But here, you don't really know what is the concentration of O2, right? So, you want to know the rate of formation. So, here, you need to merge with the one that you have up here. So, this one means that if you want to calculate the concentration of H2O2, is possible because when the concentration of H2O2 reaches 0.05, so you need to use this value. So I'm going to explain about this. Okay, so negative delta H2O2 equivalent to delta T. This one is equivalent to 2, right? 1 divided by half is 2 delta O2 delta T. So in order for you to get the concentration of O2, so 2 delta concentration of O2 delta T is equivalent to negative delta H2O2 delta T, right? So you just want to get the concentration of O2, right? So it means that you need to do this one. You'll be 1/2 delta concentration of H2O2 delta T. Is it okay? Right. So it means that here, when you want to calculate the oxygen, here, it will be the same. So from the previous calculation, delta T is equivalent to 1/2 delta H2O2 delta T. Alright, so again we write rate is equivalent to K concentration of O2. Since we don't know the O2, so we are going to use this one, right? So the same thing, so it's going to be 1/2K concentration of H2O2. And then in the question, it states that the concentration of H2O2 reaches 0.05. So 1/2K 0.05. Okay, where can we get the value of K? Remember the first one, we already calculated the value of K, which is 0.0277. So equivalent to 1/2 times 0.0277 times another 0.05. So you should get your final answer for this question should be equivalent to 6.925 times 10 to the power of -4. So this is your final answer.